So I'm going to record this, and I would like to start with myself, because I do have a presentation that talks about origami and industrial design. Since up until a year ago, I was teaching this in the University of Israel of Holon Institute of Technology. So it's kind of organized to cover, at least to present the idea of what is origami and industrial design. And then we have Philip to talk about his experience with industrial design. And then we have Adrienne to speak about more about design from the point of view of maybe fashion or the eyes of the consumer. And then we have Saadya, who is going to be talking about origami and design, or maybe industrial design, which is more of engineering design, but he will explain more. But his work is unique because his models and the origami that he's looking for is more about origami in action and less about the design as a static end product. So let me just share my screen. And so industrial design is usually about products, and a product is usually something that have a function. And I'm starting to talk about the fashion industry but this is not my main point. My main point is that when we talk about origami in design, it will usually include a change of material, because most of the things that you will see made out of that are made to be product will not be made out of paper. I think there are very few exceptions like lamps or jewelries, but I will talk about that later. So just to say that when we do talk about materials, the main challenge for a designer is either to work with soft materials, and then you have to make the surfaces between the creases more stiff. Or if you talk about hard materials like metal, then you have to make the crease lines more thin or more flexible, or to work as a hinge. So we have I can divide the word of design in origami, or industrial design in origami. I'm not going to say industrial anymore because it's just too long of a word to say again and again. So it's about either soft materials or stiff materials, and then you have to stiffen the polygons, or you have to make the creases lighter or more flexible. Another thing that when we talk about origami is either to do a replica, or will it really fold? And those two examples are really about folding something. So this dress is actually folded, and this pendant is really folded from a single sheet of material, both cases, by the way. And here we have another thing, which is about origami, but it's not really folding anything. So there are two categories here. Maybe I'm not covering all the categories, but on the right, you can see a mold that was made out of paper, and then we put inside some cement. So this is completely related to origami, but there's nothing folded here. It's a technique of molding. And on the left, you see something that most people will say it's origami, but there's no real connection between this and origami as we understand the word. But still, any polygon-shaped object that you will see, people will call it, oh, origami, so nice. And I will talk about that maybe just a bit. This on the left is maybe one of the rarest examples of designs that are using the paper as it is. And those are jewelries by Dasha. And on the right, you can see jewelries that are made on a way by molding once again. So here are some examples. This is a Komatsu elephant, and Nicola Terry rabbit, and the sonobear, which is quite used. You will see many uses of this one in design. So how do you fold metal? I'm not going to talk about that, but this is just to show that you can fold metal by sketching the crease lines on the plate, and then you can fold it to this. I don't want to go through all of that. Wood, you can fold wood, and this is not about folding materials, but more about what you can do with origami in industrial design. So this example is my doing, and jewelry is I think many people are doing jewelry, and this is one of the troubles. I will speak that at the end once again, because I have a few things to say when you go to the market with such a high quality, I can say, if I may say, high quality products in a market that the average price in Etsy for origami jewelry is about $1.5. So how do you manage to sell very expensive jewelries in a market that doesn't value origami as it is? And just a spoiler, it's very difficult, almost impossible. Wood is another material that people are trying to fold. Those are my examples, but there are many other examples. This is wood which is glued on top of fabric. So you have the look of origami. It's not really folded, but it does really give you the essence of origami. And you can identify the pattern here quite easily, which is the Miura Ori, with a lot of spaces in between the folds. But and you can see a close-up here. And what you see here are polygons of wood glued on a fabric, and it holds all together like this. And you do have movement here, but I'll let Saadya to speak about origami in action later. A few more ways to fold metal is, as I said, to glue it on fabric, and you can see it here, or on a higher scale, wood skin that are doing. And this is another example of, oh, this is origami. I don't think we will call it origami, although there are many folds here, but there's no real design here. It's just like, you just put it on the wall and it gets this shape just by the use of polygons of triangles. And here you can see how it works. There's a very thin fabric that connects all those. This is Israeli design, which also folds the wood in a very special way. I'll talk about it later. But this is another example of going into industrial manufacturing of. So this is a product that you have hundreds of copies. It's not done like I'm doing it one by one, but they have a process line that can manufacture many of those. We can talk about that later. Robert Lang, his vase, I don't know if you have seen it, but this is a very nice technique to have folds. I did this just to make a cube tessellation, a single molecule of it. And there are many problems with that. That's why you don't see that many origami products that made out of wood. It's very difficult, to be honest. There are very few of them in the market. Much more, you can see metal, and you can see much more other materials. I'm going to skip this one. This is metal. This is my product. It's a drawer. How do you say that? It's a cabinet with drawers. So you have 6 drawers here. The origami part is only the cover. Yes, of course, the wood and the cabinet itself has nothing to do with origami. And this is sold by a gallery that I'm working with, which I will talk about that later when we discuss how to develop and how to sell and how to produce and everything. Copy of origami. It's not really origami. It's actually the pieces are welded one to another, but still people will consider this as origami. And this is an important point because people don't really care. None of us, not us, all the others, we look at this and say, this cannot become out of a single sheet of metal, okay? This has some cheatings here. A lot of pieces are missing to be unfolded into a flat piece of paper. It won't be happening. But this is why when we'll talk about it, we will understand that you don't really need to maintain the rules of origami when you try to design something out of any other material or out of anything. I don't know if you know this one, Flux. This is a very nice design. It comes flat, and when you fold it, you get a very stable chair. I was sitting on those in Milan Design Week 2011. So I think it's a beautiful design with curve design. We don't see that many curve designs out there, but here another example. This is another design of mine. This is a tessellation that became to be tiles with a Casa concrete. I have a lot to say about that because for the last 4 years, they don't pay royalties anymore. They just disappear. They still sell it. They still add my name. They tag my name on Instagram whenever it is sold, but they don't pay me anything anymore. We can discuss that as well later. So this is a 3D surface, but by good design, nobody will relate to this as origami, but this is actually exactly like this design. And I don't know, I'm sure they came before me. Sometimes it doesn't really matter actually, but we will talk about that as well. Those are the molds that I was talking about for the vases. The main problem with this is that you can use the mold only once. And but if you see the result, it's quite impressive. It can be a single piece, which doesn't really make sense when you talk about industrial design. Maybe back to paper, because this is what usually is being done. And you can see when you look for origami lamps, you will mostly see those very basic patterns, or you can see the sonobe units. So origami origami designs, when an industrial designer wants to do something with origami, he will go mainly to lamps. And that's why I'm not allowing my students to do any lamps when I teach them industrial design. But there are many samples as those. This is Issey Miyake, but actually it's not true because Jun Mitani designed this one and Issey Miyake made it, or gave it his name. I don't know exactly what was going on between those two, but this is one lamp and this is another lamp which is made by, you won't believe it, the fortune teller, quite a lot of them. So what you see here are many, many fortune tellers glued one to each other. And once again, we'll talk about it as well. Nobody really cares if it's glued or folded from a single sheet or whatever. If it looks nice, then that's enough. And this is for sure origami. And this is the lamp I was working with Aqua Creation with. It's the opposite for Casa Concrete, because until today, they are still paying every year some royalties, and I'm quite happy about it. And we'll talk about that as well. So I was trying, I really did a very fast presentation because I didn't want to speak about every subject, but just to say that there are so many opportunities in combining origami and design. And you can try to do your own product and sell it outside, and you can go and collaborate with a company that makes the object that they want to sell, like I did with Casa, or you can make a special design for a lamp company. Anyway, there's so many things to say about all of those, but I don't want to cover it already. So I took about 15 minutes to set like a base, a common base. So this is what we are talking about when we talk about origami and industrial design. We are not talking about artistic elements like to sell a tessellation which is framed in because this is more into the art section, and it's a completely different discussion. So I would like to move to Philip. Did I say Philip to be the second? Yes.
Yes, that's fine.
Yep. So, and we didn't plan all the panel, but the panelists are me and Philip and Adrienne and Saadya, and then whoever wants to talk, and then we have time for questions and discussion. So let's go to Philip. I'm going to spotlight. Actually, you're going to share a slide as well.
That's way too much me.
So there's a very simple solution. Share your screen.
There we go. Is that visible?
Yes.
Okay. Very good. This is about a job I had at Tetra Pak in 2014. And In early 2014, in early January, I received an odd email from a man in Sweden that began, "Dear origami expert, I'm contacting you to be able to reach the best origami expert in the world." And I read it. The email spoke of a challenge. It spoke of a job, 2 trips to Europe, and 5,000 euro. I decided it was spam and I threw it in the trash. But it was a strange piece of spam. It's not addressed to me by name, but it had clearly been sent to me because of my background in paper folding. I pulled the email out of the spam folder and checked the headers. I looked up the website and checked to see who owned the domain. I Googled the companies mentioned in the email, and they all existed. As did Mats Dunmar, the man who had emailed me. I found his CV and the IDEON open website. It all looked fairly real. I never really did care for competitions, particularly origami competitions. But this one had an interesting prize: joining an industrial design team and traveling to Europe to work on a design problem. And money. Money is always right. It's nice. So I reviewed the challenge, and I found it an interesting one. It was forming an A4 sheet of paperboard, what we call cardstock, into a tube and then folding it shut from one end. They weren't just looking for origami people, but engineers, mathematicians, and designers. The timing bothered me some. The flyer said the challenge had started on December 16th, but the email came on January 3rd. I had only a bit more than a week to design something and enter. It seemed like short notice, but I got to work. I decided to go with curved surface work, thinking it would stand out from the other entries. And I came up with 3 designs. The upload function on the website was bulky. It just kept timing out and failing. But I was able to upload the files finally on the night before the deadline. There was a week or so after submissions went in before they contacted the participants. Even before that, I had more email from Mats at IDEON asking me about my job. He found out I worked at a liberal arts college, one pretty well known in the States. I think he found out through Google. I had the impression that from Mats that their lawyers were worried about it. I do human resources at this college. I explained what I did, that it had nothing to do with research or scholarship, but Mats requested a formal letter. The secretary of the Board of Trustees wrote me an official letter disclaiming any interest in whatever was produced in the project. I'll mention that I told Tom Hull about this, and he told me that's fairly standard. Very shortly after that, I heard I'd been selected. They sent an invitation to a webinar, what we call a Zoom call now. The timing was tricky since we had team members in the States, in Europe, and in Asia. And it didn't work very well, of course. People getting connected, dropping out, audio failing. It was Skype in 2014. Perhaps you recall what it was like. It was the first time the team ever got to meet each other. I was delighted to see names I knew, like Paul Jackson and Mark Bolitho. The people doing the choosing had made an effort to diversify the team, which also pleased me. I half expected a panel of all white males of a certain age, but I could see women, younger people, people with different backgrounds, made it look as though they knew what they were doing. One requirement that I wasn't aware of initially was speaking English. A Russian who had been selected to be on the team had to drop out when he admitted not being able to speak it fluently. It had been a long while since I'd been to Europe, and I still had quaint notions of picturesque monoglot patchwork nations. When we visited the Tetra plant in Lund, I got the lowdown. There was a sign on the wall that said English only. English is the Tetra Pak language, spoken and written in all their facilities. No Swedish or anything else. I'm not sure I ever got my mind wrapped around who and what the other team members were. Mats from Ideon Open seemed to be the director of the project, the one who envisioned how it would work and made things happen. There were several people from Tetra Pak, engineers and package specifications people. Implement Consulting Group had a couple people there as well, Eric and Mads. They were in charge of a lot of things, the logistics of flights and accommodations, the collection and verification of documents, and leading the work sessions. Really, Eric and Mads struck me as being corporate trainers. They used colorful markers and giant sticky notes, and they spoke in abstract concepts. They were more sophisticated than trainers I knew, but they were very much in that realm. One thing notable is that the selection of the creative team from the challenge was done by Ideon Open and Implement Consulting. Tetra Pak had no role in it. One question I had, and I never asked, was why us? It's not like Sweden is hurting for industrial designers. You can't swing a cat in Sweden without hitting somebody who's sketching out a design. If you don't have an industrial designer and you want one, you just have to go down to the local IKEA and see who's working at the till. So why would you import designers from all over the world? Mats from Ideon Open was a professional open innovator. He worked in University Science Park and specialized in connecting corporations with teams of outside experts to solve intractable problems. I don't think I'd come across the idea before, but I was intrigued. We signed contracts. I knew that going in. A partner firm that I never saw was the Swedish intellectual property rights consultancy, AWA Patent. I think these were the lawyers who were worried about my academic connections. We signed away rights to our contributions, and they stipulated the conditions of payment. Nothing too complicated. The contracts were remarkably readable. There were rules about not sharing any of the designs, which are entirely understandable. Tetra Pak was founded in Sweden in the 1950s using an innovation of Eric Wallenberg's, a tetrahedral milk container made from plastic-coated paperboard. The machine is delightfully simple and used heated crimps to seal the tetrahedron after the milk was poured in. In the 60s, the Tetra Brick was introduced, and that product went worldwide, not just with shelf-stable milk, but with a variety of food products. On the right, you can see a happy consumer with a tetrahedral milk carton. Note the way the tetrahedra packs into the baskets. Those are down near her feet. That's pure Buckminster Fuller. Efficient packing is a big virtue at Tetra Pak. This is the Tetra Avero aseptic bottle, the product we were to fix. On the right is an exploded drawing of the Tetra Pak laminate, the real secret of their success. The polyethylene coating is not only air and waterproof, it is also a powerful adhesive. Did you ever try to pop the corners off a brick package? It's not glue. After they pour the product in, they seal the end with a heated crimp and then fold down the corners. Before they fold them, though, they hit both surfaces with a blast of superheated air. That momentarily melts the plastic, allowing the surfaces to bond. It's simple and very strong. After the Skype call, we started receiving mailings each week from the team in Sweden, mainly inspirational stuff. Malcolm Gladwell discussing his ideas on intuition, videos of people stacking paper or cups very, very fast, teamwork stuff, and a little background on package design. There were to be 2 meetings, 2 days each, one in early March and one in early April. They were going to take place in Malmö, in Sweden, just over the bridge from Copenhagen. It was snowing heavily the day I started out for the first session. By the time I got to the airport, the first leg of my flight had been canceled. After much discussion, the airline booked me on a flight to Chicago and then to London, and 6 hours later to Copenhagen, and I arrived 45 minutes before a get-to-know-you dinner with the team. Nice folks, all of them. Everybody was quite excited to begin. In the morning, we all walked down to the Modern Art Museum where they'd rented out a gallery for us to work in. There were big tables, lots of art supplies, and welcoming furniture. Mads and Eric from Implement Consulting would lead discussions and set exercises and assignments for us. You can see some of the giant sticky notes here. We weren't getting a lot of information about what we were fixing. I think they were concerned about clouding our vision with too many details. I will tell you, you see these flaps here on the right? The base is what they call double D, an elongated octagon. It forms elegantly curved sides on the package, and those fit into the consumer's hand very nicely. The flaps on the bottom are formed of the kind of double rabbit ear, and it's folded through this thick and springy laminate. This carton is empty. If it were full, you'd see the bottom bulging out a bit, putting stress on the portions with the melted plastic adhesion. These flaps tended to detach and pop out. Since the process involved filling the cartons before sealing and folding, popping flaps represented a huge loss of product. What they wanted was a new design, one that held together better. Our goal was to come up with 5 promising candidates for that design. Between exercises, we'd have time for free folding. One of the rules was that we threw away nothing. Each new try was to be signed and saved. At the end of the day, we'd have hundreds of models. We would meet around these models and present and critique the various attempts. The engineers from Tetra Pak were fascinated. We were folding things they'd never thought of. Almost all of them were entirely impracticable. They would categorize the results and evaluate each model. And at the end, they had to rent a storage container to hold the archive. I think they had 2,000 models by the end of the process. On the second day of the session, we had a field trip to the Tetra Pak training plant in Lund. It's about 25 kilometers north, so that we could see the A6 machine in action. This is the A6 machine. As the stairs suggest, the machine is about the size of a shipping container, and it handles every piece of the carton construction and filling. The plastic laminate is rolled on big spools and loaded onto one end. From there, it is cut and formed into a sleeve. The plastic top is injection molded onto the sleeve, and then sterilized with hydrogen peroxide and filled with milk. The bottom is sealed, and then the folding and flap sealing is done. Starting it up, we noticed there were a large number of errors being kicked out of the machine. I understand there's a good deal of manual tuning which has to happen before you can get a good run, something the new bottom would fix. When the machine is running at speed, it will generate 10,000 units in an hour. Mark Bolitho and I stood watching the machine churning away, and he said, "This is like going to Narnia, isn't it?" Of course, a giant clanking machine is nothing at all like Narnia. It was the sense of the magical and the strange that Mark was commenting on. I totally got that. I should mention the support team took very good care of us. Hotel reservations, meals, transportation, everything was handled for us. If someone said the room was dark, a member would run out and buy lamps. We flew home the day that's after the second day and had a month to recuperate. We kept in touch with email and with Dropbox. I continued to brood on the problem, as is my habit, and designed a couple of new solutions. The engineers thought them a little too artsy. Frida, the Swedish design student, told me, "Swedes will never tell you when your work sucks. I did an internship in New York, and I came to understand how valuable it is to be told that." Now, Swedes are very polite. So I was told I was artsy. Oh well. The second section in April was much like the first, but rather more intense. The exercises became more challenging. One of my favorites, which we did several times, was folding in teams of 2. You had 20 minutes to fold a solution, and then you traded your model for your partners. You then had 20 minutes to reverse engineer your partner's design and improve upon it. You presented your partner's model to the group and explained its good points, and then your improvements on it. This is in every way contrary to the way paper folders work, but it made for some very interesting progress. We kept running into restrictions. The new bottom we were folding had to be radically different from the incumbent model, but we couldn't change any of the machine design. You couldn't add more steps to the folding, for instance, without having to retool a good portion of the A6 machine, and there were already A6 machines all around the world. The cartons were full of liquid when they were folded, and that meant you could only use mountain folds. That's not strictly true. Valleys would form from the mountain folds, but you couldn't get inside the model to pinch anything. I had a lively chat with an engineer about embossing the laminate from both sides, the Jeff Rutsky method, to get the folds going in different directions. But it was not something I could get across. Mountains and valleys was not industry terms. On the last day, we broke up and worked in teams, and we worked on the most promising designs that we had come up with. I volunteered to work on the idea of making indentations into the bottom, which I think was an idea that came from Heng-Yi Cheng. The engineers liked the idea, but they dismissed it as impossible. Victor Courjoli and I spent a happy hour with a couple crates of water-filled cartons, cataloging all the ways that you could make indentations. I think we had 10 different ones by the end, and we never sprung a leak. The laminate is very tough stuff. At the end, the engineers gathered the 5 most promising designs and ranked them. We'd achieved the goal, and though we understood the end result would be years off, they had to go to research and development and then to retooling. There was much celebration, and we shook hands and dispersed. A year later, the Swedes wrote to speak of the progress they'd made with the designs. They were pleased with the project and had been making presentations about it. I found a TED talk that Eric Kaiser had given. IDEON Open still lists the project on their sites as one of their successes. But it's been years now, and the Avero has never changed its bottom. In the last year, I noted that it had been removed from the Tetra Pak catalog. If you look at that, you're going to see there is no Avero package there. I would like to think they're getting it ready for a relaunch, but I wonder if they're just going in a different direction. Sometimes I think I see elements of our models in the newer packages in the catalog. That might be my imagination.
Wow. That is an amazing story.
It was fun.
Okay, so thank you so much. And now we go to Adrienne. Hi there. Long time no see.
Hi, everybody. Nice to see you. Am I on mute?
No, we can hear you.
Okay.
Everybody's smiling.
All right, good. So Ilan already gave the main points of a lot of what I'm going to have to say. So I hope it's a good review. And I've put together just different parts of other lectures I've given. So I hope that's a nice review as well. Let me see. How do I share screen?
There's a green button at the bottom.
Oh, okay. I see it.
Then you can choose which window you are going to share. Yeah. Okay.
So you can see my screen?
Yeah, we can see it.
Okay. So I'm going to talk about origamish design, as I call it, which is using origami as a tool, aesthetic inspiration for other areas of design. I was a fashion designer in New York for 11 years. And I was very heavily influenced by origami in terms of how I think about design, what I design. And I also saw origami used in a lot of different aspects of other areas of design that I'll talk about as well. So this first slide here is from the American Super Bowl, which is a big American football competition. And at the halftime, they always do a big music show. So this is Katy Perry on top of an animatronic lion. And I mentioned this because when this came out, I was immediately getting a bunch of messages of something like Katy Perry is on Origami, or there's origami at the Super Bowl. And of course, when we look at this, we know it's not origami. If we want to be annoying, we'll say, if anything, it's based on papercraft. But it wasn't a coincidence. So it's something that I call origamish. So it's anything that feels like origami. Hold on, I have to forward my slides. Okay. So what feels like origami? It's anything folded, creased, pleated, papery, paper art, paper craft, kirigami, mathy, linear, angular, geometric, faceted, polyhedral, crease patterny, basically anything that makes anybody think of origami, which is kind of what Ilan was saying as well. There's lots of stuff that's faceted, like this chair and this vase that people tell me is origami. I've always been interested in all these things. I see that there's a lot of common connections between them. Where did my slide? Sorry, I'm having technical difficulties. Okay, so this is, I'm almost embarrassed to look at this. But when I first moved to New York, I went to FIT, where we used to have conventions back in the day. And I did their accessories design program. And these are some of my old student projects. And something I realized when doing these is that when I'm designing something, I think a lot about lines and shapes. And the other people in my program didn't necessarily think like that. They might think of an overall concept. They might start thinking about materials. They might think about their original inspiration. But I always approach design with lines and shapes, which I'm pretty much certain came from doing origami since I was really young. So that was something I thought was interesting, that origami had just, kind of determined how I think about these things. And something else I'd experienced with origami is that I have boxes and boxes and boxes of folded origami that sits in a box, and I never really do anything with it. Sometimes it's on display, but mostly I'm sure we all have tons of models just put somewhere. So I like doing stuff with it that felt more permanent, or felt like there's something I could use it for. And here also some of my projects. This was early experiments, basically tessellating leather. And I didn't really know that that's what I was doing at the time. I kind of did, but I didn't think that much about it. But something I learned here was the limitation of materials, or maybe not even limitation, the possibility, and that you have to think about it a totally different way. So you can't just go and pre-crease a pig and fold it. Like, that's just not going to happen. It won't do anything. So I had to reverse engineer it, or work in a totally different way just to get it to look like how I wanted. And basically think about a lot of trial and error just to think about the structure of what I was going for. So something to think about just when you're doing origami is, how does the paper affect the final design? We talk about the best paper for doing certain models, but how might you do justice to the model if you had to use a different type of paper or a different material altogether? So, hold on, did I miss a slide? Oh yeah, so my next bit of inspiration was the Ismiyaki Bao Bao. These bags are everywhere. They're heavily knocked off. So you see them everywhere. And for me, these always look like crease patterns. And what's neat about them is you can collapse them all different ways because of the creases. Though I tend to think that this original is nice, but it's kind of boring. I've seen it everywhere. So that inspired me to do what I call a sack. It's bow bow, meaning bag. And this was laser cut with wood. It was one of my most ambitious projects. And the CP was based on a water bomb base with a few changes. And this is where design experience is valuable. I switched it up a little bit, one, to make it more interesting, and also for the structure. And because this has some non-foldable vertices, the whole thing doesn't collapse flat because the vertices won't allow them. And some origami people have told me that the non-foldable vertices irritate them. But you know, you're also not going to fold a piece of paper that looks like this. So yeah, there you have the original and the and my model. Something else I like to do is I like to play with crease patterns. I think they're really interesting, really beautiful just by themselves. And they're kind of a secret map. So if you know origami, you might look at this. You might actually look at it for a long time, as I have to do, even just to find where this crease pattern is, and you can fold neat things about them. So it's like a secret treasure map almost for me. And doing them out of laser cut acrylic, you also have the properties of that material. So if the area is too dense, it'll melt or burn. And if the area is too big, it might crack. So you kind of have to think about all those properties. And also just for aesthetic reasons, let's see. Yeah, so this was the original crease pattern. This is from Christine Edison. She's a good friend of mine. So just playing with the crease pattern, I came up with different versions. So this is the original here. When I tiled it, it looked too sparse. So I thought it wasn't that interesting. I did another one where I added a line that I tiled, and I didn't like it. So I kept going. And this is a version I really liked. And when I tiled it, I thought it looked the most interesting. Yeah, so even when I tiled this, I made this, the whole thing's asymmetrical because I tiled a bunch of this bigger one and kind of cut it apart. So the whole thing looks like it's symmetrical, but it's not, it's just a shape. And even this one, I've made the thing several times and I still have to stare at it just to find the repeat. Also did this with 3D printing. This is the same pattern, but I did it a different way. And one of my guiding principles in all these projects is that somebody should be able to appreciate it as jewelry or design, regardless of whether or not they know anything about origami. So the people here might appreciate this, that this is a crease pattern, it looks origamish, but a lot of the people on my Etsy, and I should agree with Ilan, there aren't that many people on my Etsy because people don't want to spend money or they don't understand what it is. They don't necessarily know or appreciate that it's origami, but they like the design of it. And I think there's a lot of shitty design out there that gets a lot of mileage just because people think, oh, it's really cool, it's origami, it's 3D printing, but in my opinion, the actual product is kind of terrible or it's very flimsy. There's a lot of 3D printed stuff that people buy because it's 3D printed, and I think it looks bad, although they sell a lot of that stuff, so I probably also have a lot to learn from them. Here's another one. This is a ring that I did based on a composite of Fujimoto patterns that I put together. And I posted this online and on Facebook, and Brian Chan made fun of it because he can. And he said, that's not 3D printing, that's an extrusion of a 2D thing. So he went and helped me, and he helped me facet, which is the one here in the gray, that reproduction. He helped me facet it. So the whole thing has a hexagonal cross section, which I like as a math nerd, but it did make my design better. Sorry, I have my slides and my audio on 2 different pages and it's making me slow. Let me see. So another thing I did is there was a big origami thing at the Science Museum of Oklahoma. And they asked me, I had done a book of cut and fold paper hats with the origami kirigami person, Sam Ida, who's extremely talented. You should check him out. He does very complex cut and fold or just folded pop-up books. And something I learned working with him is that sometimes a small cut can replace like 10 origami steps and make a much more elegant model. So when I worked on this, I ended up recreating everything from the book. I changed it because I thought the book was it was for a children's audience. I didn't think it was good enough for a museum, and I like to create a lot of extra work for myself. So when I was doing this, I wanted to include a lot of different aspects of origami: curved folding, corrugations, modulars, tessellations. And I also used some cutting and other techniques just to get the isn't looking at this and policing whether or not it's a square. Here's another photo of it. And something I learned in, where is it going? Yeah, in design, is that the things you like are not necessarily and often are not what the public likes. So I really like this one. The whole thing is made from one rectangle. It's a tato, and then I strategically put cuts in it. So it comes up with this whole thing. I really like it. You know, for me, that looks a lot cooler than a rectangle. I'm looking at my notes. Yeah. Oh, sorry, I missed a slide. So this here, this is some curved folding, and then the one on the right here, I was kind of towards the end. I was out of ideas, and for us, this is a simple corrugation, or to me it was, and everybody thought this was the best one, which was kind of disheartening for me because I did all this hard work on the other one, and they loved this one. But that's another lesson I learned a lot of times in shoe design, is that people like things for not the same reason that you do. And a lot of times what they like has nothing to do with what you like. And often, like, we had a rule in footwear is don't like the shoes too much because otherwise they'll drop them. Like, they often like the designs we didn't like. So something else I just learned in shoes that also applies to origami is it's really good to get feedback, because the work isn't about you. Like, once you've made it, it's what other people think of it. You know, it's not all about you anymore. It's about the work. So feedback's really important. It's good to get ideas, and it helps you think more critically about your design, and also just getting a little more a mental distance from it. So a lot of times we take all of it, including the feedback, very personal. And no, when the people are looking at you, they're not looking at you as a designer or looking at the work. They're just looking at the work and not at you. And there's a tendency among origami people and fashion people to completely overcomplicate things when they aren't necessary. And getting feedback on that is really helpful because you're looking at it from a totally different set of eyes. So this is what some other people have done that is very origamish. So something I prepared for 7 OSME that was in Oxford is a lot of the time when I was researching fashion design, these things would come up every so often, which is North American smocking. And I always thought they looked just like tessellations. And this is one of the most direct applications of origamish that you can find. I worked on this for OSME with Tom Hull, and we figured out that these are a completely different method, but they are structurally identical to a lot of the tessellations that we know that we've discovered maybe in the last 50 years. But these have been around for hundreds of years, that's a whole other lecture that I've done. And I showed this to Madonna at 7 OSME, and she's taking it to a whole other universe with it. And she has a lot of information on that, but these are tessellations, which I think is really neat. Let's see what I have here. So here's a big pile of them. I have the paper ones, I have the smock ones that I did when I was researching it. And because I'm me, once I figured out how to do it with fabric, I had to do it out of leather. And that takes a lot of trial and error because leather does not like to be told what to do. It has to be stretched, it has to be coaxed. And I didn't want to sew through the top of the leather because I didn't want to see the stitches. So I just sew through the depth of the leather, which is fractions of a millimeter. And that was really difficult. And it took a lot of trial and error. And another thing I had to do is, for years, everybody said, why don't you make origami shoes? And I never really had the right application for it. And a lot of what makes origami work is it's very thin, it's very delicate. That's not going to work on shoes. But now that I had this leather technique, I could do this. And I did make my own shoes from scratch at school, but I didn't have the equipment. So I made these leather pieces and attached them to some other shoes. So now I have shoes with origami on them. And I'm not the only one to do this. You see smocking in fashion from time to time. So Bottega Veneta is a big luxury Italian design house. There's one on the right I found from Pinterest. In the middle, you have Rihanna wearing origami. And people do all sorts of stuff on this. A lot of it is kind of crafty hobby stuff. So you end up seeing like this, stuff like this. And another place I found origami or origamish things is a technique called plissure, which I know the French people here will tell you is pleating, but they refer to the technique as plissure. And this has been around since at least the 17th century. There's an atelier in Paris that does all the plissure for the fancy couture houses, the fancy major fashion design houses, Chanel, Dior, Hermes, everybody. And what they are basically doing is really elaborate corrugations, and some of their pleat forms they've had for over 100 years. And this is how they do it. There's basically, they make a sandwich of the material with two like heavy material, I think craft paper, they use other stuff. It's sandwiched between there, they heat it. I've done this myself, and it's really difficult because you cannot have any little creases or overlap. Basically, it has to be perfect and perfectly aligned, or it doesn't come out nicely. And also, there's, depending on what the material you use, it might not make a sharp crease, it may not look nice. So this is for me was a lot harder to achieve than the smocking, at least on the scale that I want to do it. Of course, if you do this much bigger scale, it's easier. But this atelier has a lot of beautiful stuff with really complex patterns that I really like. And you see this stuff in fashion as well. There's a lot of inspiration for it. I know Ilan showed us some on a larger scale. Some of it I feel like it's a little bit forced. Like the Issey Miyake one is nice, but it's, to me, it's not well integrated. It's like, here's a bunch of nice creases, but it's not like the one on the left I find is a lot more elegant. And here's the other one. I made my own sample on the right with the blue. And I think it's really neat overall that these techniques have been around for hundreds of years, and the origami people, a lot of us are not really aware of them, or we don't really look at them for inspiration. And I find like exploring other fields, exploring other materials, there's a lot we can discover from that will, I guess, contribute to what we can do with origami. So yeah, that's there. I put together a few different lectures to do this. So you have more questions about anything, please ask me. And I have a lot more slides, and Madonna has gone way more into a lot more patterns, discussing the math about it, tessellations. She's really run away with this. So she's also a great resource for this. And yeah, that's what I have to say about that.
Okay, thank you so much. And this quite interesting. And okay, we'll talk about that, and we'll give you time for questions at the end. And hi, Madonna, you're here as well. Great. And now we are moving to the last presentation before we open the discussion to everyone, to Saadya. Saadya, are you going to have a slide as well?
I'm going to show videos.
Okay, so you still have to share your screen.
I have to share my screen. let's see, just the screen. Okay. Actually, before I share, I have a number of different hats in origami, and I think people know me maybe as an exhibitions curator, or maybe they know my sculptural, figurative work, portraits and stuff like that. But it's also, I also, for the last 4 years, I've been teaching at an engineering college. I teach one course on origami mechanisms, and for second-year students and for third-year students, I teach I co-teach. I'm not the main person. A course on products, on design and manufacturing of products that fold up, and that's the perspective that I want to bring here, where the action of the item, the mechanism is the important part, and so it's sort of an allied field, or a subset, if you like, of deployable structures, where you're using origami inspired, but mainly I'm going to talk today about the actual, what I consider actual origami in deployable structures. I'll talk about some work that I'm doing with students. I also have a couple of fourth-year projects that I've been guiding, and then and talk about a few things that don't have to do with me at all, and I'm going to make some bold, sweeping statements about all this. My preferred format would be to allow interruptions for questions, but I guess I don't want to deviate too much from Ilan's. So let's start with, let's see what I can do. I'm not so used to using this. Let's start with this. Okay, so this is a robotics project, and we're using a wheel that I designed, an origami wheel that I designed. So let's get it started. Okay. So there's the robot, and it's got those wheels on the side, and the wheels change their size on command. The commands are given by smartphone. Each wheel is individually controlled, and you can get, theoretically, you can get any size variation that you want. Sorry about that. But in practice, with this material, which is polypropylene, about 3 millimeters, 3.3 millimeters thick, you only get about 120%. It doubles in size, a little bit more than doubles in size. So this is a project that they did. It looks like the wheel's getting blown up, inflated, I mean, but they're not. They're being mechanically manipulated. And in fact, you have to leave holes in the middle for the air to come in and go out, because it's completely enclosed. Each of these wheels is made out of a single sheet of paper. Let's see. I don't know if you can see, but here it is in paper, right?
But then you have to, okay.
Okay, so this is actuated by turning the wheels, turning the center holes, right? The center holes stay the same shape, and you open it and close it. And then the difference from another wheel that it's like a Korean group made a wheel based on what's that called? The water bomb base, the magic ball, right? But that trades width for height. You're basically flattening a sphere. In this case, you're manipulating this. Right? So students here were Dor, Elmoznino, and Eudifil. I always have to mention their names. And Yoav Biton advised them along with me. So they did a very nice job. I was very pleased with it. We're thinking of using this for, or incorporating an air component, or at least an air stop component, either inflating it or just controlling the by valve. And then the application would be an amphibious robot, basically. So you'd have large inflated wheels when you go out to sea, and then when you come on shore, you get small and get better traction and also better mobility. Not necessarily better mobility, different mobility on land. That's where we're going. And what I have to say about this, besides basic showing off, is that there are other non-origami wheels that change their size, but every one of and very good ones, and using stiff material, not just this sort of thin and flimsy polypropylene, but every one of them is not a continuous surface at the edge, and because of that, you can't inflate or deflate, right? So if you want to have something where air is trapped inside the shape, you want to use something like that. The shape, we can talk about it later if you like, starts from what you might think of as a very familiar flasher, but it's different from a familiar flasher in that the original shape that it's made from is actually a cylinder, right? Pop it open, that's what you get, rather than starting from a disc with a hole cut in it. And I went to the trouble of taking a patent out. We're starting patent proceedings for getting a patent out. I'm up to the PCT stage now for this shape. So that's one project.
Are you going to share again, Saadya? Because people saw you on a small screen, because everybody, you have to know, guys, that there is a small button that you can switch between the screen shared and the video screen. So you could have seen him on a larger scale, but I think most people don't know about that. So you have to stop your share and show the wheel again, Saadya.
All right, I'll stop the share and show the wheel again. Okay, so this is the wheel in paper. I'm not going to go through the whole speech. This is the wheel in paper. And the wheel in paper is an extension of this idea, which is a cylinder. All right. So if you imagine now, the cylinder is now twice as high with a strip in the middle for the edge. The lines just continue in the same direction, and you get this, right? So this is a double wheel. This is a single wheel. That's what it's. That's.
Can you show again how the diameter is changing?
The diameter. Right. So opens, closes. Right. I'm counter twisting the circles.
Okay. Perfect. Thanks.
And here is the actual wheel. Polypropylene. It's a lot harder to do, but with the motors that they have, they're able to control it. I can only do a small amount, but they're able to get it really good. It's good and tough. I'm starting to do measurements, how much weight this can support. I'm not going to give out that information right now. Anyway, so that's one sort of project. Let me go back to before even going back to screen sharing. I wasn't sure I was going to talk about it. I'm not going to say very much. A concept that I seem to be the first, it's sort of incredible that it hasn't been reported on. You know, I'm sure Ron Resch and David Huffman noticed this because they worked on these shapes. But the fact that you got a mechanism where this thing can just change size, open and close. I seem to be the first to have reported on it, and this shape. I'm certainly not the first to have done mountain valley cone alternations, but simply the fact that you can change the shape of material by this movement continuously, in principle infinitely, in practice paper has a thickness and then it gets stuck pretty soon, in fact. This is interesting, and so I've explored various aspects of this. I had one student, I have a claim that of any folded structure from a flat sheet, this one will bear the most weight of any of them. It's not a claim that I can prove, obviously, because you would have to use an infinite number of shapes and test every one of them. But this one, which is from elephant hide, 190 grams. A student did his project and he found that it takes 5,000 newtons to crush this. Right? So it's half a ton before this gives way. And even when it does give way, it's not a catastrophic failure. You get something that still resists. So it's an interesting shape from that perspective. And another project I have, if you wind it way up, you can get a shape that looks like this. You have to leave a bigger hole in the middle to do it. And this is now a new way of getting material to roll into a tube structure, into a pipe, right? So, for instance, in reverse osmosis desalination, you're pushing things through something that's shaped like a toilet paper. Here, if you put a drop of water on it, it's going to have to go around and around and around and around and around before it comes out the bottom. So you have much longer contact with the filtration material with something like this. It's just an idea. And I'm also going to mention, this is a bold claim, because of some of the people that are in the audience, that this structure, which I also designed, or the family of structures which this is from an uncut circle of paper. It's a way of folding material, a disc, into a sphere. Right? I'm not going to do it now. My claim is that if you want, this now has 6 arms, but if you increase the number of arms, you can get the most compact ball that still on pulling it is going to come out in an ordered fashion possible. And the application would be, let's say you want to inject something very globular into the body and have it turn back out into a sheet, or sent up into space maybe, and serve some reflective or function up there. Anyway, let me get back to the share screen, and I want to talk about some other things, other people's work. So share screen. Okay. Okay, this is another student of mine did a project. Here, I'll show you what he's doing. He wants to make a mattress that sits at some distance off the ground. It's not going to show you how it looks when it's flat, but he'll open it and close it. See him close it, and now he closes it. Okay, let me stop the share. This time, this is not. This is from a what's called a Miura tube. It's one of the tube forms, the simplest of the tube forms invented by Tomohiro Tachi. He calls it a Miura tube. If you cut along here, you'll get a Miura fold up here and a Miura fold down there in this direction. That's the only direction you can do it. It has the property, he 3D printed this, that it will fold this way. You can make it from rigid materials too. This is a little bit flexible. You can fold it this way and it folds flat, and you can fold it this way and it folds flat. But if you compress it this way, it doesn't go anywhere at all. It's stuck. So it has the further interesting properties that, of course, you could extend indefinitely this way. But you could also put another tube right next to it in this direction and another one on this. So it's, if you like, you can call it tessellation in all three directions. And then it will all behave all together. It'll compress this way, and it'll compress this way. Well, this way I don't know if you have more, but it certainly will not compress this way anymore, right? So that's what he's using for his mat. This is a mattress. I didn't tell you what this is supposed to be. It's a mattress. We're exploring the idea of having a plug at the end. So you release it and it would open up and the air would come in, and then you would seal it, and then the air would be trapped. And in addition to the structural resistance to weight, it would take, you'd have the air holding it in, right? And then you'd unplug it and close it, right? So those are the sorts of ideas that we're exploring. I think I'll almost skip. I'll go very quickly because we're sort of at the end of time. This is work that exists on the internet. It's by.
You say this, you have to share your screen if you want us to see.
Oh, I thought I was sharing the screen. Let's go back and share the screen.
No sharing? Oh, yeah. No,
You're sharing now? Okay.
Yeah.
So Ilan's question at the beginning is, how much use do these products really have? Well, and I want to suggest, first of all, that some of these ideas have potential great use, but they're not for product design in the fashion sense. Here, this is a design for an inflatable solar sail, where you basically, it's one of the ways of getting a tube structure to fold up. You keep it sealed over here, and then you inflate, and it actuates a solar sail. By a solar sail, I mean, let's get this down so we can see. This over here is a solar sail. Let's get this bigger somehow or other. Let's get back. Okay. So these are the booms over here, and they pull out the mylar. So you would inflate this, and you get the mylar coming out. By the way, since we're here, this looks very much like the flasher that I showed you, but if you look very, very closely, you can see that at the ring inside, it's got these, here, you can see these lines coming down, right? The lines coming down means that the folds are getting narrower as they come to the interior, which means it's made from a circular shape, some kind, or polygon with a hole in the middle rather than in this shape. It's a little bit different. Okay, I'm going to leave it here, or not entirely leave it, but the bold claim that I want to make is that for these sorts of the sorts of shapes that have is that me, or did you do that?
I did it. I did it. It felt like you're talking.
Right. You're absolutely right. I want to make the bold claim that, generally speaking, cylindrical or tube shapes that you then make a manipulation on are more useful than flat shapes. The Murafold alone does some very nice things, but you're going to get more mileage structurally, functionally, from a tube shape, and you're taking advantage. You're also you're taking advantage of the fact that you have a continuous surface, which is an origami property that you don't have in other ways of collapsing structures. Other kinds of deployable structures don't usually and can't usually wrap the surface in a way that that controllably folds up. So I'm making a pitch for tubular structures. This is a tubular one. I don't know if it counts as origami because you can't make it from a flat sheet, but you can make it from two flat sheets that you then join. This is a from a flat sheet with a cylinder. One that I like enormously when I've studied is the Kressling tube. This has a lot of potential. It has potential both because it has various levels of bistability, where the units resist and then pop one at a time. So you can make, people are actually studying this, you could make a something that controllably collapses during an impact, during a crash, for example, by making some structure that's like this. I'm more interested in the fact that you can, by twisting, you could open one and close another. So you could make a pump, supposing that each of these has is separated and has a hole, and force air or water in or out one of these. It operates very much like a heart, right? You have the atrium opening and then pushing into the left ventricle and so on and so forth, back and forth. You could make an artificial heart from a structure like this, I think. So I'm making a pitch for tubular structures and as being more effective or having a wider range or being more adopted in this field than flat ones like Miura. Flat ones like Miura and all of the variants work very well as stable structures if you're going to sandwich them between materials, and then you can do all sorts of things. I don't deny that, but if you want the fuller functionality, it's going to be some of these tubes. That's my tall claim. Happy to invite challenges to this statement also later on.
Thank you so much, Saadya. And I think we didn't plan any of that, but I think the collection of the full presentation does present a very clear and wide look on how to use origami or what can be done with origami in the industrial design area, from engineering to fashion. I think we covered quite a lot. I think this is a good time to move to questions, specific questions that you want to ask, because either of us can speak like 1 extra hour, but I don't think it will be interesting without understanding what is the more interesting issues that you want to cover. So I'll just leave it open, and who wants to start with a question? And you can ask the question openly to everyone, or you can direct it to any of us. And okay, no one has a question, so we can call it off. Thank you all for coming. Oh, Gerardo is here. Sorry. Go ahead,
okay.
Gerardo.
So my question would be for everyone. It's a very general open question. I just would like to know, in your experience, how positive or not has been the experience to try to implement origami in industrial design, in terms of how you have felt about it, but also in terms of the market and the relation with other professionals, negotiating this whole professional zone of industrial design. So any of you, thank you very much.
It's quite a broad question. I think for me, I'll start if I may. I'm quite happy to do a lot of, most of the projects that I did were quite nice, and I was quite happy to be there. First, to be invited, like Philip, just one day out of the blue, you get an email saying, would you like to design a tile for us? And yes, of course, why not? And then this is always giving you a very good feeling. And when things really do happen at the end, then you are quite delighted. That's a very positive feeling. I must say that within economical world, or maybe the business side of it, it's not always a happy situation. For example, the kites that I designed for Casa, they are still selling them, but I don't get any royalties anymore. They just decided that they are paying too much. Maybe, I don't know. I'm not the only one. They're not paying for any of the designers, but this is something that it's very difficult to control. I know that Paolo Bascetta, for example, has a contract with a company that stopped paying him as well. And you send emails and you send letters and nothing happens, and there's very little you can do. That's a lot of frustration lying there. I can give another example, which is a more positive one, with the lamps that I designed for Aqua Creations. All I get is 2.5%, by the way. So it's out of the sale, they sell. It's not that much money, but all in all, it was a very positive experience, especially because the lamps were published and they got some coverage in the media, and then they went to Milan Design Week. So sometimes when you have those opportunities, it's a pure pleasure. But I think out of 10 people who came to me to talk about industrial design, maybe one project became reality. Like I have tens of suggestions that I started to think about, to work with, and then the other side just disappeared, especially when you don't have the contract yet. So it could be highly frustrating. I got a phone from a lady who wants to design lamps for children's rooms. And then she gave me the brief. And after that, I never heard from her again. And you start to think about it, you all the things in your head, you're waiting for her second email, and it never comes. And why? What's happening here? And it's very difficult to. Another experience that I had was with the jewelries. I was sure that I have a hit. I got very good feedback. Everybody said it's beautiful. I put it on Etsy. And then for a year, I sold 6 through Etsy. And I took a course. The course was much longer and expensive than all I got from the sales on Etsy. So it's not that easy. When it works out, it's beautiful. When it doesn't, then it's just like every other project that you cannot manage. So all in all, I will always say yes. If it's a reasonable suggestion, I will always say yes, because I like those opportunities.
Thank you, Ilan.
Do we have other people who wants to answer that? Maybe Adrienne, Saadya, Madonna? Yeah.
I can. So all of my little things I've done have been for me. It's something I've been thinking about, something I wanted to do. So the main goal is just, it's something I want to do. It's something I want to see if I can do it. Because some of the things I don't even know if I can do them. And the fun part is figuring it out. I think we've had lots of jokes and real conversations that there's almost no money in origami. I might make tens of dollars on this. I think I've sold 20 pieces on my Etsy in all the years. I also just don't do anything to promote it or sell it. And it's there because for a long time I didn't have a website and people wanted to know what I do. So an Etsy was easy and occasionally I sold something. But for me, the motivation is entirely just to come up with a project that I think is fun. And if anything happens with it, then that's great. But I expect pretty much nothing. And I'm just doing it for myself, especially working as a commercial designer, like in fashion and shoes. They're gonna tell you almost exactly what they want. There's very little room for creativity. They don't care who you are as a designer or what you can do. They say, we want this product for this price point that looks like this. Wow. And then 15 people have different opinions that all conflict and you have to do everything. So as a creative person, that's super boring. So this was kind of me doing jewelry, shoes, whatever, was me having a creative outlet where I didn't have to listen to anybody. So that for me was the most rewarding part.
Okay.
Thank you, Adrienne.
I guess I'll jump in. I have a long history in origami, but my academic field is philosophy.
Oh.
and equally impractical, right? And so I've gone into this world of mechanical engineering, and I'm teaching mechanical engineering students, and it's very exciting to be exposed, first of all, to be exposed to a real practical field where people are being taught something that's useful to them. It's a complete different academic environment than what I'm used to. And then, so students are all into 3D printing. So they make things like this. So I learn about that. And I learn about desalination and how it's done. And I learn some robotics. And it's exciting to meet, to have this encounter with these different fields, and they like, they're as attracted to origami as anybody else is. So so that's been nice. Stepping out of the academic world poses challenges now, and that, I guess this isn't exactly the question that you were asking, but a lot of these shapes are incredibly hard to manufacture by mechanical means. So getting out into the real world means solving automated folding processes that are folding and gluing that are kind of beyond where the world is right now. So the world isn't entirely ready for this. I mean, you can 3D print anything or almost anything, but if you want but it's costly to do it, and that's not, if you want to compete with a shape like this against mattresses that have very, very simple inflatable mechanisms, then you have to solve this problem. So far, it hasn't been solved, but we're going to head in that direction.
Okay. More answers or more questions? Madonna?
I have a couple stories and a couple shiny objects. So my experience with industrial design mostly stems from a project that I worked on this summer. Someone reached out to me and asked if I would work on a mechanism to pleat for making masks. And it initially went decently well. I was under the impression that they were looking for someone to contribute design ideas. And it's my understanding by the end is they were looking for someone to outsource the whole project to. And so eventually I talked them into getting an actual mechanical engineer, and that person proceeded to solve the problem without any folding itself. So sometimes origami is not the answer, but it was interesting to work on. And I learned a lot of things. And in terms of shiny objects, I've got a very shiny one. Speaking of the smocking that Adrienne was talking about, I've been working on a variety of things. The trick with smocking is that it pretty much has to be done by hand, because it is that fine needlework and getting all of these little points stitched together. It's very difficult to make in mass numbers. So something like this would probably take me 4 hours to make, which is not in accordance with the prices that the market is necessarily willing to pay for a Christmas stocking. Likewise, for a scarf, people aren't really willing to pay $100 for a scarf, but that's the time investment that it takes. And what I've found most recently is if you can get a tessellation, and got some backlighting there, and set it in acrylic, then this is a pretty straightforward solution. I can get these laser cut, comes out to about $3 per frame. And I already did, what, 5-6 grids while we were talking today. So it's very straightforward to do, but it took me 2 years of iteration to come up with something that simple when I was working on origami as a business full time. So definitely lots of work.
That always will be the question. How can we make money out of origami? Okay, so do we have more questions, please? I thought David wanted to ask something.
Yes,
Yes, I
there's
actually
one
do.
on the chat box.
There's one on the chat box, but David wanted to ask before. So
Oh, of course. I just wanted to mention this one. David, sorry about that. Go ahead.
No worries, no worries. That was actually addressed to the artsy type over there. You mentioned something about designing and working in groups, which is something in origami is not all that frequent, at least that I'm aware of. It's not something that we really do a lot. And when it comes to the corporate world, it seems to be very keen on doing all the team exercises, group thinking, whatnot, which I find tedious. But you did mention that you were working in pairs, Philip, and I would like to know whether you had the impression that was actually a good way of producing not only necessarily applied origami solutions, but perhaps also even more mundane things, such as the stuff we do for pleasure.
Yes, as I was saying, it's totally not the way origami people work. We're like cats. We work by ourselves.
Yeah.
And yeah. And so the idea that we would sit down with somebody at the same skill level or a different skill level and trade back and forth, reverse engineer, I thought it was brilliant. I was doing this with Mark Belitho. We got to understand each other very quickly. He would make something, I would take it apart, do a variation of it, and he would do the same. It's kind of like a conversation in slow motion. I would love to see this happen at conventions. I think it might make a very interesting way of creating new models that would not be associated with the individual, but with the group.
Okay. So waiting for that to happen at conventions.
Well, no,
definitely.
Maybe it would be on Mondays in New York. They do technique and various other things. I think it would be a good way to do it there. I think I attended something similar when the Italian guests were there. Maybe Daniela can tell us about that, where they were doing kind of a group creation thing. It wasn't quite as dynamic where you're trading back and forth, but it was a group creation thing.
Okay, because I must admit I'm quite let's say prudent about this type of approach in origami, because we all are always very personally involved in what we fold. But I do wonder whether it might be worth it giving up ego for a little while.
Yeah.
A little while, I think I could tolerate.
Telling my 5 cents, this kind of creation process, I've attended to some occasion of this process during the nights of Italian convention, but it was really something amusing. It was not done for a business, but it was done as a play. And so there was also a lot of joy involved in this process. And I was happy of hearing Philip talking about that workshop, because I knew about that workshop that was told by me by Victor Corjoli. And so I'm happy to have here another point of view about that workshop, and about hearing that the same creation process, common creation process, can be used also in an industrial environment and for business purposes. So it is very interesting seeing creativity used for something that is worthy. So it is very interesting. It is not common, the process of creating something together, and it involves the fact that people shall come on the same wavelength. So it is some way of thinking in a common way. So it is very, very unusual to find, but when it happens, it is very funny to be part of it.
Thank you. Ali, you wanted to say something?
Yeah, it's not a question. Thank you all for the presentations. It was very interesting. So last July, I attended a workshop, which was the research department in the Stuttgart University, the computational design department, and one of the PhD students there, Iranian, she studied in the MIT and started this research. So the research they were doing was autonomous origami. The idea was pretty simple. If you take a sheet of paper and put a layer of plastic tape on one side and then spray water on it, you see the curve and curvature in the paper due to the fabrics trying to crumple. So they found a way to control this in thicker materials, naming woods. So I put the links, the keywords and the videos into this chat for you to later see. And they designed not only furnitures like tables with thick sheet of wood, which when exposed to the moisture, it was getting folded, and later on when it was drying again, it was becoming flat. And they also designed a tower with this mechanism, and that was one of the interesting workshops that I participated in. So probably this is an interesting thing, since we're here in the applications of origami in the products and architecture, to check it out. The first link is the brief about the workshop that I said. The second and the third is about the products and also the tower architecture, the application in the architecture.
Very cool. Oh, nice. Okay.
So since Adrienne is here and she gave her talk about origamish, I wanted to show something which has nothing to do with the mechanical stuff that I was talking about before, which is the opposite of Adrienne's style, where I don't so much care that the thing looks like origami, but I kind of wanted, so here's a little, it's made, this is leather, right? So, but it's folded from one piece of leather. So here you can see it.
Is it going to be something at the end?
Well, I was working with a friend who has a leather workshop, and I had exactly 2 days, and I made a whole bunch of things on the same principle, right? But this was going to be some sort of
a bag.
Some sort of bag. I have, like I said, I think I have a total of about 8 hours experience working in leather. So it's much less than Adrienne has, but I would think of this as a sort of side satchel or something where you could clasp it or whatever. Yeah, it would turn into something if I was design minded. So we'll see.
Okay, do we have more questions beside the technical question of Evie about how to stiffen paper, which I think at one day we will dedicate a talk about folding other materials, but I don't want to go down that lane just today. So if you have more questions, this is the time. Nobody's asking about money.
We know the answer.
It's not completely true, because in some cases you can find some money in this. It's not that easy, but just for example, the lamps that I designed, I get every year about 200 to 500 euros out of this. So I do nothing. I put a lot of work at the beginning. It was 10 years ago, but still every year I get a few bucks, which is nice. So not everything is so dim and black in the world of origami and design. There is some light at the end of the tunnel. And when I do sell a jewelry, it's for about 400 euros or 300 euros. I'm not talking about conventions, but I sell them for 50 or 70. But other people that don't come to conventions, they pay full price, and then it's nice here and there. But it's a very good question about origami and money, and I think we can open a full discussion only about that. But this is not today. We already discussed this twice, I think. Yeah.
I think there is light, but it's good not to expect the light or to do something for the sake of the light, because the light may not be there and probably isn't.
Yeah,
but the light is nice when it's there.
That's a very good point. Yeah, I agree. Don't expect the light, so be surprised when the flash comes. Yeah, and sometimes it's a flash, and most of the time it's just a candle, but there is a light. Okay, and no more questions?
I would have a second question, but strangely, it wouldn't be for any of you. It would be for Ali, actually.
Perfect. It's okay. We are paying.
So,
yeah.
And I want to remind you, Ilan, that if we have time, you mentioned you might want to talk about what you studied about Instagram.
Oh, if we have the time, yeah, I can. But here there is completely no light.
I know that part, but you mentioned you studied something about numbers.
But let's make sure that this discussion is finished when we go to a new topic. But yeah,
I
thank you for reminding me.
So anyway, my question was for Ali. I just wanted to ask if have you found any use of your origami knowledge for user experience design, or have you ever found any use of your user experience design on your origami designing?
Right, that's a good question, and surprisingly, somebody else asked me this question today, and I realized that I have never thought about that a lot. For those of you who don't know, my day job is as a UX designer or user experience designer for mobile application softwares. So it's less about the visuals and more about the system designs and how the people interact with the applications in terms of working with them and interacting with them. The thing that I think that had the most commonalities between these two worlds is that I realized that when I was doing origami before, so it's been 4 years that I've been working as a UX designer. Before that, I noticed that I was very much focused in creating experiences in my teaching and in my introducing origami to the audience. So experience design in a broader sense is a service design. So you want to be creative with how to introduce this and how to consider the audience in what you do. So some of the things that also Adrienne talked about is that sometimes people do not love your work for the reasons that you love them, and this is a very, very important issue in user experience design. So you always have to validate and ask for the user's feedback in whatever you design. And there's no designer per se in terms of that I know how to do this and how to design this. You always have to be mindful about what you design, which is mostly should be functional for the users of that. That was one side. So service design and also listening to the audience and the user. The other hand is that at least my origami is less mindful, more about being serendipitous and also being surprised by what comes out of the result. So this really helped me in terms of not planning everything from the beginning when I'm designing a feature or discussing the feature with the team. So that's also, so being comfortable with the ambiguity and not knowing all of the things that you want to do. So these 2 points were actually the things that I was thinking about today when earlier in the day, somebody asked me this question.
What a coincidence. Thank you, Ali.
Yeah, amazing.
You're welcome.
Okay. Ilan, you are unmuted. Are you going to ask a question?
Yes. So I have a question. It's more about on the side of the investor designer.
Okay.
How much the origami application is involved in your work as a designer? I mean, how much the application of origami is in designer, you think it's at the place for it?
I'm not sure that I got your. You want to say it in Hebrew and I'll try to translate?
כמה יישום אוריגמי באמת מעורב בעשייה שלך?
שלי באופן אישי? שואל אותי?
בתור מעצב, כמה אוריגמי מעורב בעשייה שלך?
Okay, so the question is, if you are a designer, how much origami is involved in your daily doings? And of course, this is a question for all the people who talked. And I think I would say in my design, everything that I do is about origami. So it's like 100%. I don't design anything which is not origami because I don't feel that I have any benefit out of that, or I don't have any leverage, or I don't have any special knowledge that allows me to do anything that is not origami. So my designs are completely origami. Or maybe sometimes I will design a solution how to hang a piece of origami or how to connect two pieces, or like in the metalworks. So it's not always fully completely origami, but I try to solve all my issues just by folding flaps or folding hangers. And so I'm going to use one material and to do all the solution with a single sheet. So origami is my 95% of my designs are origami. I think Madonna will say the same, but I'm not sure about Saadya or no, Madonna, no.
No, so since I shifted more to teaching, I think the majority of my time is spent in administrative things, in making sure that all of the links are good, writing things for writing emails, getting everything ready for people to see. And then the gridding and the workshops themselves are a fairly small portion of my day. And I'm lucky to finish a piece of my own every week.
Oh, okay. Okay. Does it answer your question? You know?
What? Yes, yes.
Okay. Do you have any more question marks? No? So first I want to say thank you for all of you to come. It's very delightful to see 35 people at the moment. So even just to listen, it's important for us to see you all. And thank you for all the people who talked. Philip, for a beautiful story, which is, I heard about it from Victor for a very short, brief time. And you gave a full description, which was wonderful. And Saadya and Adrienne, thank you all for being part of the panel. And we have only 3 more minutes to finish the 2 hours that we give always to this meeting. I would like to ask if there's anyone who wants to be our guest for the next. Do we have anyone, Dasha?
We do have.
Oh, okay.
I've forgotten. He's from OAS group. He was here. He left. What's his name?
Fernando.
Yes,
right.
I think he's our guest, but we will have a free spot in
Just
Fremont.
after that, yes. So if you want to be our guest and present yourself and your work, I see quite a lot of names that didn't do it until now. So maybe it is a good opportunity. Don't be shy. If it's possible to say don't be shy, and people are not shy anymore, but yeah. So we would love to hear about you. And I think we keep the Instagram insights to another time, because there are not that many insights. It's quite just to show you how a full year of effort brought that number of followers, but there are no real insight about it. So yeah, that is all. Thank you all so much.
Thank you all. Thank you very much.
Bye-bye, guys.
Bye.
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 Hello.
Thank you.